Okay, well today we're going to be talking about 6-1 solving systems, and we're going to do this by graphing. Okay, so to solve systems of equations by graphing and to analyze special systems is our lesson objectives. Okay, our standard is A1.3.1. Alright, a system of linear equations is basically two or more linear equations together. So we're going to talk about putting two or more line equations together in one problem. The solution of a system of linear equations is the solution that works in all linear equations of that system. Okay, so basically we're going to start out where do they intersect, and we'll talk more about that. Okay, so essential to understanding is why is this important is that we can use systems of equations to model story problems. Okay, so a lot of times in life we need to figure out a problem, and system of equations is the process about going in and solving those problems for maybe a business or something. Okay, so first off, let's start with kind of a simple one. What is the solution of the system? Use a graph. So basically what we're going to start out with is we're going to graph this first one, and I'm going to put this in blue, so I'm going to put a little blue star over here so you know. How do we graph a line? Well, we start off by the y-intercept. It goes up 2, so we're going to plot that up 2. And then our slope is 1 in front of the x, so we're going to go up 1, run 1, rise 1, run 1, rise 1, run 1. So that's what we're going to do to start, and then that's going to be our line. Okay, so I'm just going to draw a line across here as we go. Get this, and I'll straighten this out a little bit. So there's our line. Okay, so that's the first one we have. Now let's look at the second one. Second one's -2. So we're going to go down 2. We're going to plot that point. But this one we're going to go up 3 over 1 because our slope is 3. So it's 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay. And so it's pretty simple. I mean, we've been doing this stuff for a while now. You're going to draw your line again. So you're going to have two lines. My lines aren't color-coded, but my points are there, so you can follow along with that. And then the solution is basically where do they intersect? Because if they share a point, that means that that point will work in both equations. So that's what we're looking for. And it looks like they both intersect right here. So that would be 1, 2. And it's up 1, 2, 3, 4. So 2, 4 looks to be the solution to this. Now we can check this by plugging in. 2 plus 2 is 4. So we plugged in 2 and we got out 4. Plug in 2 here. 3 times 2 is 6. Minus 2 is 4, which is what our y-coordinate is. So it checks out. Make sure though that you give me your answer. Don't graph it and say, hey, it's right there. I want to make sure you know what that coordinate is, that you know that's where it crosses. Okay, so make sure you write down 2, 4 as a coordinate. Okay, so example number 2, solving the system by graphing. I'm going to go ahead and do this one on your own. Make sure you're using graph paper, and we'll check that when you come back. Okay. So let's look at problem number 2. Problem number 2 is a story problem. Scientists study the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator is listed below. After how many months did the alligators weigh the same amount? This information is also on page 361. Okay, but I went ahead and provided it for you. Okay, so let's write an equation for alligator 1. So the first thing we have to do is write these equations, so that way we have something. Well, the equation is going to be based off of the weight. So the weight of alligator 1 is going to be the total of its growth rate, which is 1.5 pounds per month. So we're going to put M for months, plus its initial birth weight, which was 4. Okay. The second one, A2, had a weight of a growth rate of 1 pound per month plus initial weight of 6 pounds. So there's our equations. Okay, we'll go ahead and look at the second part, which will start to find the solutions where they'll be the same amount. Okay, so now let's look at how to graph these. And again, it's just really the same thing. Once we have the equation set up, it's really the same thing. So put the first one in red here. We're going to start at 4, 1, 2, 3, 4 units up. Okay, and 1.5, which we need to know what that is. That's actually 3 halves. There we go. 3 halves. That's going to help us if we put it in a fraction form, because that's rise over run. So 1, 2, 3 over 2. Rise 3 over 2. Okay, that's going to help us in plotting that information. Okay, as we go through, we're going to say plus 6, 4, 5, 6. And this one's going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, because that was our slope. Okay, so now when we graph these two lines, put that one there, and I guess I should put this in blue. Let me quickly put that in blue so we can tell the difference between these two colors. I'll key that, that's in blue. And then we'll draw a line for that one. And you'll notice that they seem to cross right here at that point. So we go 1, 2, 3, 4, and that's up at 10. So that means after 4 months, the alligators will weigh the same amount of 10 pounds. So after how many months? The answer would be, in this case, so make sure you answer the question, 4 months. The point of intersection is 410, but the question is 4 months. Okay, so example 4, talking about satellite TV. I want you to go ahead and read through that problem and set up that. You might have to adjust your intervals to get the information in on the graph. Okay, problem number 3, talking about many solutions, infinite many solutions, and no solutions. So we have particular special types of graphs here. So we're going to go ahead and work through this one. Let's go to the first one here. Now this is a unique case. We can actually put this in, because it's in standard form, we can do x and y intercepts. So if we make y 0, so the height is 0, x has to be a -2. Okay, so it would be 0 minus x, which is -x equals 2, which means x is -2. And then we make 0 for x and solve for y, which means y would have to be 1. Okay, so that's, again, putting that in black. So that means there's my equation right there, and there's my line. Okay, I'll make the next one in blue, so I'll key that as blue. This one is in slope-intercept form, so we just go plus 1, and then we do rise 1, run 2, go down 1, back 2, rise 1, go 2. And what we'll actually find out in this case is, and it's kind of hard to see, I have to change this a little bit to make sure we get this to fit. But this one actually has the exact same equation. Now we didn't change that first top one, but we'll do that now. If I change that by subtracting or adding x over, what I'm going to get is x plus 2 equals 2y. Now when I divide, what's going to happen is I'm going to get a 1/2 here, and I'm going to get a 2 over 2 there, which means that that actually becomes a 1. Okay, let me go ahead and erase that. So that becomes a 1. So when I add x over and divide by 2, I get 1/2 x plus 1, and what you'll notice is that they have the same slope and the same y-intercept. We talked about in perpendicular and parallel lines that means that it's actually the same thing. So this is a infinite many solutions. Okay, so you can just write many solutions. That's fine for me, because it's the same line. You do need to write many solutions though. Okay. Now if we look at the second one here, part B, if I go up 2, and I go up 2 over 1, up 2 over 1, I'll get my first line, which gets me there. And then I do the second one, which is -1. Let me put that in blue. Okay, which is -1, but it's up 2 over 1, up 2 over 1, up 2 over 1. And when I go to graph that one, you should notice that they're running side by side now. Okay, so they're running side by side, which means they're parallel, which means that where are they going to cross? Well, they're not going to cross. So this one would be a no solutions. Okay, and again, for both of these, you need to state that. You can't just say, hey, look, they're parallel. You need to actually say no solutions. Or, hey, they're same line. You need to write many solutions. Okay. So that's what we talked about in this lesson, systems by graphing. So graph them, where they cross is their answer. We'll stop there for this lesson. You got, again, the pre-quiz and the worksheets that we'll work on. But that's it for now.